In this section, we're going to be covering a lot of ground. This section is probably the most foundational to this course, and it drives a lot of what we will be doing throughout the rest of the sections. Infrastructure operations is the facet of IT that often goes unnoticed outside of IT itself. Even developers often find it to be a mystery, and business folks might just mistake it for help desk. This side of the business is often one that's underappreciated, yet achieving some of the greatest feats in actually running the operations of the business. It all comes down to fundamental system administration. However, at the time of this video, we're in a world where system administration has evolved a bit, and it's evolved into this concept of development operations, or DevOps. DevOps engineers, or platform engineers as they're commonly referred to in the industry, deal a lot with what is essentially cloud-based system administration. There are so many new technologies and so many new ways to implement new technical stacks that these new DevOps type roles range from doing everything around, configuring cloud-based virtual private servers all the way to writing Bash and Node scripts to automate build pipelines. And these will impact, continuous integration and continuous deployments, or CI/CD if you're not familiar with that. Now, for our purposes, we're going to try to focus more on the concept of configuration management and desired state. Now, traditional data center hypervisor technologies like ESXi, for example, have always had features to help making migrations and backups and even managing machine states easy to configure and execute. Now, some feature functionality is a little bit easier than others, and it really just depends on what the tool is. It's not always as clean as it could be. Now, we've used a little bit of Terraform already in this course, but this is the section of the course where I'm going to break down why it is we're using that. You see, Terraform is an example of a language and toolset for infrastructure as code, or IAC for short. With IAC, you can configure entire environments in your cloud or even your data center by simply running a single command. You can even build custom pipelines in your CI/CD to do it for you. So all you have to do is, say, merge in a pull request in GitHub, and it'll go build out your infrastructure for you. It's kind of insane. Now, while I'm mostly using AWS for examples, Terraform supports multiple providers, and there's even some open source support for some lesser known providers like Proxmox. I would use these at your own risk. I haven't really tested them or vetted them, but I have seen them out. And I think it's really cool to think about how much could be automated even outside of something like AWS. Now, there are also other technologies that exist, like Chef and Saltstack, that allow you to implement this concept of desired state across your systems. You could use Terraform to spin up your systems, and then configure a custom Saltstack agent, and then Saltstack can manage the state of your systems from there. Technically, you could even have Saltstack do more. Chef, Puppet, and Ansible are all other tools of this nature as well. They all help you achieve these same goals, because at the end of the day, the goal is desired state. It doesn't really matter what tool you use to get there. So what does desired state mean? Well, desired state is this concept that a system should exist in a specific configuration at all times, never deviate. And if it does, it should be self-correcting or even self-healing. So for example, if a port is open that's not normally open, it should close itself once that's noticed. Or if a software package is installed or uninstalled that isn't supposed to be, it will return to a state where that wasn't the case. Now this isn't like point-in-time recovery, it's literally just correcting its configuration and how it's set up. It's still going to be running in real time. Now obviously, depending on exactly what and how is changed in a given configuration, this could result in issues. Anything from 5 minutes of downtime to a full-on kernel panic. It just depends on what's changed. But generally, the benefits far outweigh the risk. But I make note of that risk because, well, for one, I'm a security professional, and two, it's worth noting that this concept sounds heavenly, but nothing is ever perfect in IT, no matter how good it may sound. That said, it is still pretty sweet. And both the concepts of infrastructure as code and desired state can go a long way in red team operations. So let's get our hands dirty and build a small setup using Terraform and Saltstack, just to learn a little bit more about DevOps that we can use throughout the rest of this course. Alright, so for starters here, I've got this little repository that's coming with all of your course materials and stuff like that. And it's got some Terraform in it. I also got a nice little README with some instructions. So I'm going to step through this Terraform, starting with the Salt Master. Now, this Terraform is going to configure 3 different Linux servers. It's going to configure 2 Salt Minions and a Salt Master. but only one of them is really special. The other two are just standard Ubuntu servers will open up SSH, but this one has a special network rule allowed that is configuring ports 4505 and 4506. This is going to be our Saltstack master. This server will be able to issue commands to and configure our other two servers via Saltstack. The other two servers are just plain old Linux boxes, like I said. There's nothing special about them. They have SSH open, and for the purpose of this lesson, I can easily access the systems, but otherwise, they're just fairly normal systems. Now, a note on having open SSH to the world. This is usually a terrible idea. You can easily restrict this to IPs with network security groups, and we even have the ability to do that here. I've got a variable that you can actually configure if you just want to lock this down to your host. So with these network security groups, you can only allow access from a single IP or a range of IPs, or even via VPNs or specific spaces. Or you could even implement a jump box configuration of some sort if you need to expose something different in that sort of manner. So there's a lot more secure options than what we're doing here. And while it's true that we're configuring hacking tools, we still don't want our own systems to be compromised. Our tools can have vulnerabilities too. As professional ethical operators handling potentially sensitive client data at times too, like passwords and different credentials, is equally, if not more important, that your systems be more secure than your clients. There are certain access control liberties that you can take to run an operation where deemed applicable, but don't think that you can just leave default creds on and skip all the basics of configuration. That is an extremely poor taste. All the good fundamentals of system administration apply to the red team operations as well. Now, all that said, I wanted to go through the process of manually configuring Saltstack, since it's likely a newer technology for most of you watching this video. But agent installation can be easily automated even with Terraform if need be. In fact, I encourage you to take that as an extra exercise if you want to challenge yourself. See if you can figure out how to configure the Salt minion and master installations using just Terraform. If you do it, feel free to tag me on Twitter and post your repo or something like that. I'll likely check out your code at some point. So the first thing I want to do is go configure the Salt master, but before we can do that, we actually have to spin up our servers. So we're going to run a Terraform plan, if we're in the right directory, of course. So let's go into our base Saltstack directory. You can see here we have our Terraform file, so we'll run a Terraform plan. And this is going to tell us what it's going to do before it actually does it. So we can see here it's going to configure a couple different hosts all through, and it kind of summarizes at the beginning. It's got a base state for the AMI Ubuntu, minion 0 and minion 1. I may want to change this to Ubuntu master a little bit later on. I'll probably push that up in the repos, but since we're not later on in the lesson yet and I'll be clearing out these resources, this will be fine. But I make note of that to keep in mind because this Ubuntu AMI is used across multiple sections in the project, and if you're configuring multiple servers at once and not cleaning up after yourself, you may want to make note of that. Okay, so looks like we're configuring our 3 servers and it looks like everything's going to work out great. We're going to add 5 things. So let's run a Terraform apply. It's going to run through the plan and then prompt us if we're ready to execute. We'll say yes. And this actually shouldn't take too terribly long. Spinning up these Ubuntu servers isn't too hefty of a task, but once we're done, we're going to need to make note of the IPs of all our hosts so that way we can use them later. All right, cool. So here are our outputs. These are the IPs of all our hosts. So we have our masters and our 2 minions. So I'm going to copy these out, and I'm just going to put them in this README for now. I'm going to be referencing the README a lot, so that'll be helpful. Okay, so the first thing I want to do is configure the Salt master. So we're going to go SSH into that, get all the installation packages set up, and go from there. So let's do just that. I'm going to SSH in using my key that I've configured. And the default user on these Ubuntu AMIs is Ubuntu. Awesome, so now we're in. So what I want to do now is I've got this link over here referencing the repo Saltstack Ubuntu. And this is actually just the full setup guide for how you install Saltstack on Ubuntu. And it starts off by adding the GPG key for the actual repository. Then you're actually going to need to go into a app list file to add the Saltstack repositories. This way you'll actually just be able to apt install a lot of the packages and tools you need. So we're going to run vim and get this source in there. Awesome. Now all we have to do is a sudo apt update. And one thing that's important to note is that Salt is a privileged tool, meaning that the minions and masters run as root users. And that'll be a little bit important to note once we get into our desired state. But for now, all we really need to do is run an apt-get install salt-master, and this will set up the Salt master for us. It'll even actually start it, and there's not much more we need to do outside of configuring our minions next. So while this is running, we're going to hop over to one of our minion boxes. We'll start with minion 1. And we'll SSH cool. And we'll do the exact same setup steps that we did before, only this time we'll have to install the actual minion tool, not the master tool. And the minion tool requires a little bit more setup than the master does. All right, we'll run a sudo apt update again. If we go look at our master, it looks like we're all set up and good to go over here. And then we can install our Salt minion. Now, our master is already configured and running, should be working great, but the minion, once it's installed, like I said, requires a little bit more configuration. So let's go ahead and prep for that while we're waiting on that install to occur. So the first thing that's a good practice is to actually get the fingerprint of the master. So this is going to be a public and private key kind of association, so you can do integrity checks against the master you're going against. There's actually potential attacks against Saltstack for man in the middle, where you can actually intercept agents and pretend to be a bad master. And it's really not that hard to do. But Salt has put in a compensating control for this where you have a fingerprint. And if your fingerprint doesn't match what the master is telling you on your initial communication, the minions won't successfully associate. And this is a really good defense against that type of attack. So I always recommend doing it. It doesn't take much to set up. So we'll have our fingerprint there. And we also need to get our master IP so we can actually tell the minion what master it needs to talk to. So it looks like that's all set up. To set up everything I was just talking about, most of the core configuration files are in the directory etc salt. So the config that we're looking for the minion is actually just called minion. So we'll open it. And the first thing we'll do is set up our master. So on the master line, you could give it a DNS name, an IP, whatever that you have. And then we need to go get the fingerprint that we got. So this will be the master.pub. And we're going to look for the master finger line in the config and just paste that between those quotes. And now we're ready to go. So now we can actually say, the minion shouldn't be started, but just in case it is for any reason, we can restart it. Or you could just systemctl start the minion. But now it should be online and operational. And if we actually go back to our master, we can actually list what hosts are trying to talk to us with the salt key command and passing it the -l flag. So it looks like we have one unaccepted key from that host that we just set up. Now I'm going to go set up the other minion real quick, just so you can see that we're accepting multiple minions and able to control multiple minions. But I'm going to skip through that for the video's purposes, so you don't have to watch me do the same thing again. All right, cool. So I've just configured the other minion and restarted it. If we list them again, we now have two minions that are connecting back to us. So let's accept those both. You can do attack A to accept all, or you could just specify specific minions, but we want them all, so we're going to accept them all. And now if we list, we can see that we actually have two accepted minions. Awesome. All right, so cool. Now we have our minions onboarded, and we're almost ready to get into desired state. But first, I just want to show that we're actually executing commands successfully. So we can run the salt command, and remember it's privileged, so we have to run sudo. And you can specify minions or even pattern match on naming conventions that you may have throughout your environment. It's kind of got like a regex type deal going on with how you can specify the name. So just a star says, give me everything, every minion that I have, make sure you run this command. But that's important to note because you could have Windows-based minions that aren't going to be able to run Linux commands. So to run just like a command, you do command.run and then pass it the command you want to run. So in this case, we'll do an ID. And we can see both of our minions have successfully called back with the ID command, and the output is that they're running as root. So that's important. The salt minion is also a privileged minion running as root. So if you compromise a salt master, you've got root access to tons and tons of systems, assuming you can root the master itself, right? So that's just important to note because we're about to get into that desired state stuff. So let's dive into the desired state stuff. Most of the actual state management and handling is going to occur on the master itself. And the directory that occurs in is the /serve directory or /srv. So as you can see, this directory is actually empty. We actually have to make the directory salt. So everything related to states usually goes in /serve salt. So now that we have the salt directory, I'm going to go ahead and do a preparatory step. You can do this a number of ways. I like to do a folder-based structure where you can have some flexibility, but you can name your salt state files the name of the actual state. For example, we're making an add user state, so you could call the file adduser.sls. But what I prefer to do is make a directory called adduser. That'll be our states directory. And then we will have in it an init.sls. So we'll actually go ahead and set that up now since we're here. So we'll init.sls. So we're in a project here. We actually have the init.sls for what you'll need. And this is just going to be an add, Nix-based user to a system. And so we'll add this here. And what it's doing is saying user.present. So if this user is not present, do this. That's kind of a weird way to phrase it, so I guess I'll say it differently. User.present means make sure this user is present. And so what happens is if the user is not present, it'll make it so, and if it is present, nothing will happen. So this is very declarative syntax. You're saying this needs to exist. And so you can almost think of it as okay, if it doesn't exist, do it. Right? So we're going to create a user called Gretchen with the password of password, best password ever, right? So that's going to be our state. To actually execute the state, we need a top file. Top files control all of the states that are going to be executed based on different environment variables, different system names, whatever have you. We're just going to use a simple base state and add the add user state to it. Our base state is going to say, hey, all systems are file roots is going to be the serve salt. So you could actually specify other directories where you're storing your states if you want to have different structures. That's fine, but this is kind of the basic layout for it. And we're going to say, hey, go check out the add user state and apply that whenever we run a state apply. So we're going to set up our top SLS. And that's all there is to it. We're actually ready to start serving up some states now. So the benefit of this state is that we're now going to pre-configure a user called Gretchen across all our systems. So maybe this is a user account or a service account that we want everywhere all the time. It'll have special privileges or whatever. As you saw in the state, it's just an account that has some level of privileged access. It's kind of got like a root group and just basic setup. So it's really nothing fancy, but think of it in that context. You could set up this user for any kind of need for your specific environment. And if ever it's removed, we could easily add it right back. So if somebody, playing around on the system and misconfigure something, we can get things fixed. But you'll also notice we stored a plain text password in that state file, right? Now, storing passwords can be kind of scary. Granted, you do need root privilege access to get to these credentials. I have to be root to read that file. But when we think of it that way, we aren't accounting for scenarios of privilege escalation. More importantly, though, it should be noted that if you're on a system that is a salt master and you want passwords for a minion, you already control the master and everybody has root access. That's why I brought that point up multiple times now. So you have root access to all the minions already, and you really don't need that password that you were looking for anymore. So in that light, this is kind of a fairly low risk issue, but people reuse passwords. So a password is always valuable loot for an attacker, even if they already have all the keys to the kingdom. So Saltstack does have a solution for this. They allow us to create what's known as a pillar. And pillars are simply configurations that contain variable data that we can use in our salt states. One of the things that we can do is actually configure a GPG key, encrypt the password that we want to use for our Gretchen user, store that encrypted password in a pillar, and Saltstack will automatically be able to decrypt it to use when it's needed whenever it runs a given state. Now, that's a bit outside the scope of this course. This isn't a lesson on Saltstack. We've already touched a lot more Saltstack configuration just at the bare minimum that we need to get the point across. And so we more just want to focus on the tools that we have available and the concepts of desired state itself. However, consider the pillar thing an extra challenge for you to go try for yourself if you're interested in learning more about Saltstack. All right, so now all we need to do is execute the state we made. So we could run straight into a state apply, but we want to be able to test things. So much like we had a Terraform plan that just showed us what was going to happen before it did, state apply has the argument of test. And so we set test equal to true, which means it's just going to run the state apply, but not actually execute it. And it'll tell us what the output would be. So it goes across both these systems, says, hey, this user is not there. So the user Gretchen would be set to be added. And that's what would change. So now we can take away the test line and just apply it. And just like that, looks like it added the Gretchen user exactly how we needed it to. All right, so let's go look at one of those systems and see if Gretchen's actually there. We'll just cat the passwd file. Looks like Gretchen's here. So if we sudo su into Gretchen, awesome. We are now Gretchen. And Gretchen is in the root group, so we could actually technically do some stuff. So cool, our Gretchen user's there. We're all happy that we're there. Awesome. Now what I'm gonna do is remove the Gretchen user. And then we're gonna see how Salt behaves whenever we test our state again, and it sees that the user isn't there. So we're gonna say sudo del user Gretchen. There we go. And then if we cat the passwd file, we'll see that the user Gretchen isn't there. If we try to sudo Gretchen, there's no entry for the user Gretchen. Oh no, our Gretchen user is gone. That's not good. So let's see what Salt says about that. So we'll run a state apply where test equals true again. And it knows. It says, hey, that user isn't there anymore. This is not the state that we're normally in. And so if I run that state apply again, it'll add it back to just that system. So as you can see, we have just one total states run and only one change is made on one host. It didn't impact the other host at all because the Gretchen user was still there. So now we can go look at our passwd file again, and yay, our Gretchen user's back. Awesome. Now, that was just an introductory example. And even though we used Saltstack and Terraform, please remember that these are just tools for a job. Any tool that you deem to be better to meet your needs, I highly encourage you to go for it. Never stay loyal to a given tool. Use what works best for the job that you need. That's why it's called a tool. What matters in this case is what helps us achieve IAC automation and desired state configurations. Now, we won't actually touch Saltstack anymore for the rest of this course, but if you're interested in some more Saltstack stuff, especially from an offensive security perspective, I recommend that you check out the Red Team Village talk I did that I mentioned in the introduction. While we won't be using Saltstack, we will be using quite a bit more Terraform throughout the course. This is going to help us automate spinning up servers for our infrastructure and all that kind of stuff. So I hope you've learned quite a bit from this section. There's no hands-on assignment for this portion, just a quiz, but if you want to try what we've done here today, the resources that I've been using will be provided to you and open sourced. So I highly encourage you to give it a try for yourself. See you in the next section.